In the given example, our plaintext is communication and our ciphertext key is computer. So how we can convert our plaintext to ciphertext? First of all, we need to identify the 5 by 5 Playfair matrix and we need to put all the character in our 5 by 5 matrix that is given in the key. So in the given key, computer is there and we need to put all the character in our 5 by 5 Playfair matrix. After that, we have to write the alphabet from A to Z, but whatever the characters are already covered in the key, that we have to exclude from the alphabet key. So first of all, we have to start it from A, then B, C is already done, then we are removing the C, then after C we are taking D, then E is also already done, then we will go with the F, then G, then H, then I and J will be taken in the one place as per our Playfair Cipher rule. After J and K, J, I and J, there will be K, then L, M is already done, then we will write N, then O and P is already done in the computer keyword, then we will go with the Q. Then R is also already done in our key, then after R there is S. Then T is also already done, U is also already done. Then we will write here V, W, X, Y and Z. Now let's we cover our all alphabets from A to Z in our 5 by 5 Playfair matrix. After that, our next process is we have to take our plaintext characters. So what is our plaintext character? Communication. So we have to write this character as communication. Now, according to the first rule, we need to take a group of two characters in one place. Suppose we are taking a group of two characters and our first group is CO, that is C and O. And next in the next group we are taking M and N. But as per our rule, we are not taking our two letters in one place. That's why we have to take our C and O in one place. After that, we have to write M and we need to add one bogus character, that is X. Then we will write here M, then U, then N, then I, again C, then A, then T, then I, and last one is O and N. So for communication plaintext, we have taken a group of two characters in one place and we will form total 7 groups. This is a group number 1, then 2, then 3, 4, 5, 6 and 7. Now let's start with our encryption process. Earlier we have seen in the previous video, there are 3 rules for encryption. We have to check the characters or alphabets are there in the same rows, second one in the same column, and third one it is in the diagonal. And this rule will be checked it for group wise. In the first row, there are two characters, that is C and O. So we need to map this C and O in our 5 by 5 matrix. So in the first row and the first column, there is C alphabet is there, and in the second column and the first row, O is there. So for C and O, how we will find out our ciphertext letter? If the characters are in the same row, so here we are following our first rule. if the characters are there or alphabets are there in the same row, then we have to take the next right alphabet from the character. So from the C, O is the right one, and for O, M is the right one. So for C, we can write the ciphertext as O, and for O, we can write the ciphertext as M. Now we will do it for the second group. The second group consists of M and X. So this is our M and this is our X. Now these two alphabets are there in the same column. So whenever the characters or alphabets are there in the same column, then we need to take the character or alphabet below from it. Now for M, we can write it as R, and for X, we can write the character from the below letter from the X. But here, there is no character is there from below the X. That's why we are taking the character from the first one, that is M. Now for M and X, we are writing the ciphertext as R and M. Now in the third group, the two characters are there, two alphabets are there, that is M and U. So this is our M and this is our U. For M and U, we can write the characters from the same row and that is right from that character. For M, we can write P, and for U, we have to write the characters that is C. Now our next alphabet is N and I. So for N and I, find where it is N and I. This is our N and this is our I. Now these two letters are not there in the same row as well as not there in the same column. So how we will perform the encryption process? We have to take the diagonal characters from that same row. So for I, we can write G, and for N, we can write S. So for N, we can write here S, and for I, we can write G. So whenever the characters are not there in the same row and same column, that time we have to take the diagonal characters from that same row. In the fifth group, the characters are C and D. So now let's begin with the encryption of the fifth group, that is C and D. So this is your C and this is your D. Again the characters are there in the same column. So for C, we can write the character that is T, and for D, we can write the character that is K. Now let's begin with the sixth group, that is T and I. For T and I, find out whether the characters are there. This is our T and this is our I. So again the characters are diagonal, that is not in the same row as well as not in the same column. So that's why we are writing the characters that is there from the T, and here that in the T row we find out B, and in the I in the row we find out D. So B and D, this is the ciphertext for our T and I. Now let's begin with our seventh group. In the seventh group, the characters are O and N. So this is our O, this is our O, and this is our N. So for O and N, again these characters are there in the diagonal matrix. So whenever characters are there in the diagonal, that time we are doing the third rule. And in the third rule, what is given? We have to take the character from that row. So for O, we can write M, and for N, we can write L. So this is our ciphertext for communication. Now we have done with our encryption using Playfair Cipher. So for communication plaintext, we got the ciphertext like OM, RM, TC, SG, TK, BD, ML. And we have to follow the three rules. For the encryption, we have to check the characters are there in the same row, same column and diagonal.